Dear students, welcome to the problem solving session on Z transform using the properties of Z transform. The first property is very obvious, linear property, so we don't want to worry about it. In this session, we are going to solve problems using first shifting property or frequency shifting property or damping rule. If Z of f of n is equal to capital F of Z, then Z of a power n into f of n is equal to capital F of Z by a. This is called as frequency shifting property. And the proof is very easy. Just for your reference, I'm showing it. Now, using the property, we are going to solve some problems. In 8 marks, they can ask, find Z of r power n cos n theta. We know that how to derive Z of cos n theta and Z of sin n theta. If you don't know, just go to the playlist, watch the video. We can see how to derive both. So now once you derive both, you write the formula. Now let us write the formula. Z of cos n theta is equal to Z into Z minus cos theta divided by Z square minus 2Z cos theta plus 1. Next we have to find Z of r power n cos n theta. R power n or a power n, whatever it is going to be the same. So now using the formula a power n into f of n, I am going to write this as Z of cos n theta, and finally Z is replaced by Z by r. So first we have to find this Z of cos n theta and replace Z by r. We know that Z of cos n theta from the previous video. Now substitute Z by r in places of Z. It is very easy to take the LCM. From this, numerator will become Z by r, Z minus r into cos theta divided by r. In the denominator, we have Z square minus 2ZR cos theta plus R square divided by R square. If you take the LCM. Now what will happen? This R will cancel with R square. The remaining data will get exist. Therefore, Z of r power n into cos n theta, it is going to be Z into Z minus r cos theta divided by Z square minus 2RZ or 2ZR cos theta plus R square. This is the final answer. Similarly, if they ask you to find Z of r power n into sin n theta, the same procedure. We have to write by first shifting theorem. It is going to be Z of sin n theta where Z is replaced by Z by r. Now when you replace this, we will be getting Z by r sin theta. When you take LCM, the numerator is Z sin theta by r. Denominator as usual like the previous one, Z square 2RZ or 2ZR cos theta plus R square divided by R square. Now R square and R will get cancelled. This R will go to the numerator. So my answer is going to be ZR sin theta divided by Z square minus 2RZ cos theta plus R square. So that is the simple application of shifting property to find the problem when it is in multiplication, like R power n into sin n theta or R power n into cos n theta. Now in exams they can ask you very preciously a power n sin n pi by 2. If it is a part B big question, no other go, we have to solve and find this. If it is a 2 mark or 4 mark question, we can write the answer directly, like we know that Z of sin n theta. From this, I can find Z of sin n pi by 2. Now when I substitute here, numerator will become sin pi by 2. Sin 90 is 1, but cos 90 is 0. So we'll be getting Z square plus 1 in the denominator. Therefore, Z of sin n pi by 2 is going to be Z by Z square plus 1. Now applying the shifting property. By first shifting property, a power n into sin n pi by 2 is gonna be Z of sin n pi by 2 when Z is replaced by Z by a. Now we know the property and now apply the property. We have Z by Z square plus 1. z is replaced by z by a. When I do this, I'll be getting z by a whole square plus 1. When I simplify this, I'll be getting az divided by z square plus a square. Therefore, this is an MCQ. Remember, a power n into sin n pi by 2 is going to be az divided by z square plus a square. Similarly, we are going to find z of a power n cos n pi by 2 using shifting theorem. Now find cos n pi by 2. When you put pi by 2, cos 90 is going to be 0. So I'll be directly getting z square divided by z square plus 1. Next, applying first shifting theorem, z of a power n into cos n pi by 2 is gonna be z of cos n pi by 2, where z is replaced by z by a. That is nothing but z by a whole square divided by z by a whole square plus 1. So when you take LCM, z square by a square, in the denominator z square plus a square by a square. So a square get cancel. We'll be getting the answer z square by z square plus a square. And now we go for a very interesting and simple problem, z of n into a power n. So we use property, then I can write this as z of n, where z is replaced by z by a. And very important, student, you have to write the property. You cannot simply say by property. Write the property, get the score. Otherwise, you lose your score. What do you have to write? If z of f of n is capital F of z, then z of a power n into f of n is going to be f of z by a. And we remember the formula of z of n. If it is a part B or big question, we have to derive z of n. Otherwise, just substitute. Z of n is z by z minus 1 whole square. Then z should be replaced by z by a. Therefore, when I simplify, I'll be getting z minus a whole square divided by a square. So a get cancel. Your answer is going to be z of n into a power n is nothing but a z divided by z minus a whole square. Very important results for MCQ. Next, we have to find z of a power n by n factorial. Now, first apply the first shifting property. We'll be getting z of 1 by n factorial. Z is replaced by z by a. And it is an immediate formula. You know, z of 1 by n factorial is e power 1 by z. So e power 1 by z, where z is replaced by z by a. If it is replaced, we'll be getting e power a by z. Just a quick recap. Till now, we learned what is the formula of z of 1, that is z by z minus 1. Z of a power n, that is z by z minus a. Z of minus a whole power n, that is z by z plus a. Then z of n, z by z minus 1 whole square. Z of cos n theta, z into z minus cos theta divided by z square minus 2z cos theta plus 1. Z of sin n theta, that is z sin theta divided by z square 2z cos theta plus 1. From this, we get different variations, that is z of cos n pi by 2, it is going to be z square divided by z square plus 1. Z of sin n pi by 2, it is going to be z by z square plus 1. Similarly, if you have z of a power n into cos n pi by 2, then we will be getting z square divided by z square plus a square. If it is z of a power n sin n pi by 2, it is going to be a z divided by z square plus a square. And very important, students, the left hand side is the operator. It should be capital Z. The right hand side, whatever the answer we are getting, it is a small z. And then finally we get z of a power n into n, or z of n into a power n, that is going to be a z divided by z minus a whole square. And similarly, z of a power n by n factorial is equal to e power a by z. So just remember these formulas, which is going to be play a vital role in finding inverse z transform.
Thanks for watching. Subscribe to our channel and share to your friends. See you in the next video. Bye bye.